All right, here we go. The last video of this series of videos for the EOC review. And we are picking up where we left off with number 85. Given the triangle ABC, if PC, segment PC measures 24 centimeters, find the measure of PX, I'm going to squiggle that right here, and XC. Now, you may remember, hopefully you do, that whenever you have medians of a triangle, the three medians of a triangle intersect in a point such that that point divides the medians, each one of the medians, in a way that the small section is 1/3 of the length of the whole median, and the larger section is 2/3 of the length of the whole entire median. So PX would be your smaller section. That would be 1/3 of the entire length of that median. And XC is going to be 2/3 of the entire length of the median. The median that we're talking about, PC, is 24 centimeters. So for PX, you say 1/3 times 24. And for XC, 2/3 times 24. Of course, you can find 1/3 of 24 by saying 24 divided by 3 and getting 8. And if you want, you can just subtract that from 24 to get 16, or you can take 2/3 of 24 and also get 16. So that is that one. Find the perimeter of a trapezoid with vertices located at, and they give you the coordinates. Round your answer to the nearest hundredth when necessary. So on this problem, you have to, again, like we have in the past, use the distance formula. So x2 minus x1 all squared plus y2 minus y1 all squared. And you want to find the length of each of the sides of your trapezoid. Now what I did on my paper was I drew my trapezoid as though I were drawing it on a coordinate graph, and I didn't try to draw it to scale or anything. I just put my points where about they would be. 3, 4 would be on the right. 1, 4 would be on the left. Those would be the top pieces. M at -2, 0 would be bottom left, and N would be 7, 0 bottom right. That way I could get an idea of the lengths of the sides that I would need to find. So for example, if I start with LQ, to use this distance formula, I'm just going to do it a couple of times and then just give you what each one is equal to. So I would plug in for this. I might call, let me see what I did on my paper. I called this x1 and y1, the 1, 4, and I called the 3, 4, x2 and y2. So I just plugged and chugged 3 minus 1 all squared plus 4 minus 4 all squared under the radical. So 4 minus 4 is 0, 3 minus 1 is 2, 2 squared is 4, and the square root of 4 is 2. So the length of LQ is 2. So you go about doing that for each of the sides. You pick your x1 and your y1, you plug them in, and you find the length of each side. And when I did that, LM was 5, QN was approximately equal to 5.66, and MN was 9. So test those out in the distance formula, make sure you get those lengths. And then it says to find the perimeter. So go back and reread your question. You're being asked to find the perimeter of the trapezoid. So you just add those numbers together, 2 plus 5.66 plus 9 plus 5. So 21.66 units would be your perimeter here. C. 87, what is the volume of the CD case shown below? A CD case is an example of a rectangular prism, and the volume of a rectangular prism is area of the base times the height. And you've learned this before, geometry, as length times width times height. So your length times your width would be your area of your base. And in a rectangular prism, basically, you have 3 numbers and you multiply those 3 numbers together. So just 8 times 1 times 8. So 64 cubic millimeters. Remember, volume is in cubic units. All right. Number 88, calculate the area of triangle BAT with altitude AM given these vertices. And I actually broke out a little piece of graph paper to actually graph this so that I could tell the parts and pieces that I needed to find the distance of using the distance formula, because you don't want to find the length of every side on this one. You just need the length, the base times the height. So when I graph that, I'm just writing out the distance formula for you so you remember it. That is one that you'll need to remember for the EOC. But when I graphed it on a coordinate grid, basically it looked like this, and I'm just kind of jotting it here. I actually use the coordinates on my graph paper, but it looks pretty much like this. And it says that point M is at 3, -3, and so what happens is that AM is going to be your height. The altitude of your triangle is your height, and so BT would be the base, and AM would be your height. So you're only going to have to use the distance formula twice. You use it to find the height, and you use it to find the base. So you plug in those coordinates for your x2, x1, y2, y1. So for A would be 3, -3. For M, -3, 3. And when I plug that in for AM, just so you can practice and see if you get the same, is 6 square root of 2. And when I plugged it in for BT, I got also 6 square root of 2. So those are actually equal to each other. Kind of nice. Then to find the area of this triangle, area of the triangle is equal to 1/2 base times height. So 1/2 times 6 square root of 2 times 6 square root of 2. And what's nice about this, because they both have a square root of 2, is when you multiply square root of 2 times the square root of 2, you get 2. Remember, that gives you the square root of 4, which would be 2. So we have here 1/2 times 6 times 6 is 36. Square root of 2 times square root of 2 is 2. And so that would give us 36 square units for the answer here. And that is letter A. Great. Number 89. I was going to use a voice for one of these. Not sure if I'm going to run out of time for that or not, because none of these are simple enough to do that. This one might have been, but we'll just go with the regular voice today. Sorry to disappoint. Dylan is building a wooden cabin. The cabin is 30 meters wide. He obtained a bunch of 17 meters long wooden beams for the roof of the cabin. Naturally, he wants to place the roof beams in such an angle that each pair of opposite beams would meet exactly in the middle. So we want this to be right in the middle. And here are the beams that would meet to make the roof. What angle should be the angle between the roof beams and the cabin? So this angle right here is the one we're looking for. Either round to the nearest hundredths place or leave in terms of a trigonometric function. So it gives you a hint here. We're going to be using a trigonometric function. Please excuse the announcements. If that comes down and meets right in the middle here, then that means it splits this 30 in half. So this would be 15, this length from the blue dot to the edge over here. So we can use cosine because we have the adjacent side and we have the hypotenuse. So we just need to find the angle. So we're going to use the inverse cosine. So cosine of x is equal to 15 over 17. Okay, so remember in your calculator, you would press 15 over 17, 15 divided by 17 equals, you'll get that number. Then you hit the second button and the cosine button. That gives you the angle whose cosine is 15/17. And you should get 28.07 degrees. Okay, so the angle whose cosine is 15 over 17, and it's written like this. The inverse cosine is 28.07 degrees. All right, number 90, Abraham works at the delicious cake factory. Yum! And packages cakes in cardboard containers shaped like right circular cylinders with hemispheres on top, as shown in the diagram below. Abraham wants to wrap the cake container completely in colored plastic wrap and needs to know how much wrap he will need. What is the total exterior surface area of the container? So it looks here as though we have a half of a sphere, that is called a hemisphere, and part of a cylinder. So we have to think through how to find the surface area of each one of these. So we do know that to find the surface area of a sphere, hopefully you know, it is 4 times pi times radius squared. Well, this is half of a sphere, so you want to take half of 4 pi r squared. So to find the area of the hemisphere, you would take 2 times pi times radius squared. Then we have, and we'll just think about that a minute, and then we'll actually put some numbers in. Then we have the cylinder, and the volume of a cylinder is found by taking the area of the base. Volume, sorry. The surface, did I say surface area? The surface area of a cylinder, let me write that here. Surface area of a cylinder is found by taking the lateral area and adding to that the area of the two bases. To find the lateral area, you take the perimeter times the height, but in a cylinder, the perimeter is the circumference. So that would be diameter times pi, since we have diameter here, or 2 pi r if you have the radius. Now on this one though, because we're only covering the outside with our saran wrap, we don't need to cover this base of the cylinder. We only need one base. So instead of 2 bases, we have 1 base. So now that we've thought this through, and we're going to add those 2 numbers together, let's actually put some numbers in. So for the hemisphere, we have 2 times pi times radius squared. Now our diameter is 10, so our radius will be 5 inches. So radius squared would be 5 squared. So 25 times 2 gives us 50 pi. Notice your answer is, all of these answers, A, B, C, D, are all in terms of pi, so you want to make sure your answer is in terms of pi. So this is the hemisphere's surface area. Now for the cylinder, we want to take the diameter times pi times the height. So we have the perimeter times the height. So 10 pi times the height of the cylinder, and then that's the lateral area, and then add to that the area of the base. The base is a circle. The circle's area is pi r squared. The radius is 5, so 25 pi. So we have 40 pi plus 25 pi, and the surface area of the cylinder part is 65 pi. Now we add the 65 pi plus the 50 pi to get the total surface area of this cake, 115 pi square inches. Fun! Wasn't that fun? I know you loved it. All right, 91 is extra fun. At a garage sale, Jason bought an aquarium shaped like a truncated cube. A truncated cube can be made by slicing a cube with a plane perpendicular to the base of the cube and removing the resulting triangular prism as shown in the cube below. Okay, you're going to have to follow me here. If you take your cube, so we've got our cube. This is not a beautiful cube that I'm drawing, but you take your cube, that is, if you take your dimensions from over here, 24 by 24 by 24, and you subtract from that cube the little triangular prism that you take out. So it looks like this. You're taking that out. You're cutting it out of your cube, and you'll have left this shape here. You see it? Of course, this is part of the shape too, but it looks like that. If you're looking from the top, you have this shape at the top here. But all you have to do is find the volume of the cube and subtract from that the volume of this little triangular prism that you took out. So the volume of a cube is easy, length times width times height, right? 24 times 24 times 24. Area of the base times the height. Volume equals area of the base times the height, length times width times height. Well, in a triangular prism, same thing, area of the base times the height. This time, though, the base is a triangle, and it is a right triangle, so that's convenient. What happens is we have to figure out what the pieces are of this triangle that got cut out. So you need to find out this and this. Those are the base and the height of your base of your triangle. So it told us that the whole length here is 24, and this little piece is 9. So if that's 9 and the whole thing is 24, that leaves this piece to be 15. Same with the other one. This piece is 9, so that leaves this piece to be 15. So we have what we need to find the area of the base. It's a 15 base and it's a 15 height for the triangle. So the area of my triangle, which is the B, is 1/2 base times height. And then the height of your prism is going to be the same, 24. Its height is 24. So you multiply and you get 24 times 24 times 24 here. You plug that into your calculator. You subtract from that area of your base, which was 1/2 times 15 times 15 times the height of your triangular prism. Plug all that in your calculator, divide by 2. That's 2,700 cubic inches to give you 11,124 cubic inches. Fun. Watch that again if you feel like you need to, but 11,124 in your little box here for your answer. I'm going to take a second now to give first period their code word. Their code word is aquarium. How appropriate. First period, your code word is aquarium. Now let's all turn to the last page. Woohoo! Yay! I hear you cheering over the internet. Okay, number 92 is something we have not covered in my classes, density. But I have a way for you to remember density. It's a heart. If you think of density as a heart, I know that's ugly, but then you just put this little line here. Density is equal to mass over volume. But think of a heart. You know how you do the little 3 on the side and then the little, whatever that's called. Usually you use a less than or greater than sign on the computer. Well, an average classroom measures 20 by 30 by 10 feet. If the maximum capacity of this room, if the room this size is 45 students, what is the density of the classroom? Now in this problem, it's not the perfect problem, but they are considering 45 students as the mass. Then you would use this length, width, and height to find the volume of the classroom. So it's a little bit weird because you wouldn't usually think of people as mass, but density equals mass over volume. And for this problem, the mass will be the students, and the volume will be the cubic feet that we get when we multiply those 3 numbers. So simply, it would be 45 students over 20 times 30 times 10, so 6,000 cubic feet, to give us 0.00075 students per cubic foot. I would hate to have to split students up into 0.0008, too many zeros. Let's move this over to here. It should be 0.0075. Even still, I would hate to have to split students up into 0.0075 of yourself, but here, let's make that as ugly as we can. 0.0075 students per cubic foot. All right, this one, the picture is not beautiful, but basically we have a triangular prism. Can't really tell it very well. Maybe if I dot some lines back here and bring this down, you can kind of see it better. I don't know, but there. It says Amy bought a candle in an unusual shape, I'd say. The base and the top of the candle are congruent right triangles. The dimensions of the right triangular base legs are 6 centimeters and 9 centimeters. If the height of the candle is 10 centimeters, what is the volume of the candle? So again, the volume of a triangular prism is area of the base times the height of the prism. And on this one, the base is a triangle. So to find the area of a triangle, it's 1/2 base of the triangle times height of the triangle. And actually, let me turn that into a right triangle so we can use that to put our numbers in. So I'm just going to turn it this way. Okay, that's not really accurately drawn. That's okay. 6 and 9. So you would just say 1/2 times 6 times 9. And so for your area of your base, that's 27 square centimeters. So for your volume, 27 times height of your prism, 10. So simply 270 cubic centimeters would be your volume of this triangular prism. Yay. Second period, your code word is Mario. Second period, your code word is Mario for really no reason, but it is. Okay, 94. Jennifer works at a shipping store. She is responsible for making shipping containers. Currently, she makes 2 different types of containers. The smaller container is in the shape of a cube, and the larger is in the shape of a rectangular prism. The larger container has a length that is 25% longer than the length of the smaller container. Fill in the blank with the missing percentage. The volume of the larger container exactly blank percent of the smaller container. So what I did is this. I said the length of one of my sides of my larger container is 25% larger than the lengths of my cube sides. So I assigned some numbers. I just picked a 4. I said if each of the sides of this cube is 4, what would the length of my larger container be? Still 4 and 4 here, but my length would need to be 25% larger. I don't know if you've ever done this before whenever you're shopping with your mom, but to find what 25% larger would be, you would take your 4 and you would multiply it by 1.25 because that's the 4, and then the 0.25 is adding in the 25% more. And when you multiply that, you get 5. So our length would be 25% longer, so it would be 5. Then I just used this example and said, okay, so my volume here would be 4 times 4 times 4, 64. My volume here would be 4 times 4 times 5, 80. And I said, how much larger is 80 than 64? And I divided 80 by 64, and that gives me 125%. So you get your decimal, you move it twice to the right to get 125%. So the larger container is 125% of the smaller container. If you get anything less than 100%, question yourself because it has to be larger. So it has to be at least 100% and then plus some. In this case, plus 25. Last problem of the packet. I need to hear some cheers over YouTube, y'all. Woohoo! A package shaped like a rectangular prism needs to be mailed. For this package to be mailed at the standard parcel post rate, the sum of the length of the longest side and the girth, the perimeter around its other 2 dimensions, must be less than or equal to 108 inches. Figure 1 shows how to measure the girth of a package. What is the sum of the length in inches of the longest side and the girth of the package shown in figure 2? Now, what they might ask you is, would you be able to mail this standard parcel post rate? They might take it one step further. So you have to find the measurement and then see if it is less than or equal to 108 inches. So we'll ask that question at the end. So it says to find the sum of the length of the longest side. So my longest side here will be 42, and the girth of the package. So distance around just the middle of the package. So we have 10 and 10. Can't really see it on here, but if you've printed out the packet or if you have the packet, you can see this is 11 and 11. So the girth would be 10 plus 10 plus 11 plus 11. So 42. Actually, sorry, that's the length. That's the length of the longest side. Eek. And that's 19. Sorry, that looks like a 10. Oh my goodness, this is the last problem. Can't get it perfect. 19 plus 19 plus 11 plus 11, the girth would be 60. Plus the length of the longest side. I guess I could have done the longest side first since that's what they asked for first. Of 42. And so that, what did they call this? They just called it the sum of the length of the longest side and the girth would be 102 inches. So would I be able to mail this standard parcel post rate if it's less than or equal to 108? Yes, and it is 102. So yes, I would be able to send the standard parcel post rate. Third period, your code word is Disney. Third period, hopefully you've made it this far. Your code word is Disney for those 5 points added to that quiz that we took on your formulas for the EOC. First person to come in and tell me those code words will get those 5 points. Thank you for watching. Hopefully these videos have helped. Go back and re-watch them to get ready. We don't have much time left, but I know you've got this. Study. We want 100% pass rate. Let's shoot for the stars. We can do it. Remember these different websites that you can go to for extra help. The Escambia website is a great place to go. They have some other links that you can go to. Math Open Ref for your construction help. And then my OneDrive in case you need the packet that I have been using throughout these videos. Remember, you're amazing. You got this. Let's do our best and go get them.